Corporate finance practice problem using OneNote. Cumulative voting problem 3. Get ready, it's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon left-hand side, Practice Problems tab, down in the 1715 Cumulative Voting Problem number 3 tab. Also note, when using OneNote, take a look at the Immersive Reader tool. Our practice problems will be mirrored in the text area, same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon. Information up top. We're going through the calculations down below. This is the third problem for the cumulative voting. We're going to go a little bit faster. If you want a more simplified problem, take a look at problem number 1. This will be another scenario that we can take a look at. The scenario being, how many shares are needed to elect directors? We want 5 directors out of 9. Remember, as we think about these cumulative problems, these cumulative voting problems, there are generally 2 calculations we can think about. We can think about 1, how many shares do we need to get to in order to lock down a certain number of directors, in this case 5, or 2, we could think about, given the number of shares that we have, how many, if we consolidate our votes, how many directors could we then vote for? Now, recalling that the cumulative voting is kind of compared in contrast to the standard or straight voting system, in which case, if you are voting for something like the board of directors, and remember the board of directors basically represents who we're going to vote for as basically the owner. So the shareholders then are kind of like citizens. If you think about a democracy, like the U.S. democracy, you'd say, well, the shareholders are the owners, and they're going to vote for someone to represent them. That's going to be the board of directors, kind of like a citizen voting for someone that's going to be in Congress or something like that. And then the board of directors are going to hire top management, the CEO and so on, the president and whatnot. And then top management is going to manage the day-to-day operations. So we then, as the owners, are looking to hire the board of directors, who then is going to hire the management. And we can do that through the votes. And we're saying that there's going to be a certain amount of board of directors. There's no hierarchy per se with the board of directors. There just needs to be a certain amount of them on the board, and then they're going to, vote for stuff and make decisions in terms of who should manage, and that kind of thing. So we then want to determine how many, votes we can get for the board of directors from our level. Note that also this same kind of concept could be applying to something like a nonprofit or other type of government organizations where you have a similar type of structure. You could see the cumulative voting there as well. So we want to see how many shares we would need to get 5 out of 9. So that's kind of a lot of the directors, right? We want the 5 out of 9 on the board. The outstanding shares are 250,000. The formula to figure this out with the cumulative voting would be shares required equals the number of directors needed times the number of shares outstanding over the total number of directors to be elected plus 1, and then taking that entire thing and adding 1 to it. You can, of course, do this algebraically. If you're expecting to do this on a test question or something like that, then if you need to know the formula, you got to memorize the formula. Also note, when you're thinking about the other type of calculation, when you're thinking about you have so many shares and you're trying to see how many directors you can lock down, it will be a similar calculation, and we'll take a look at that shortly in a later problem. So we're going to break that calculation down into our table here, and then it's useful to think about it intuitively, to think about what it actually means. So we got the shares that are going to be needed. I'm going to break this down into a table. This is good practice to be able to do when you generally are breaking something down into a table. I would basically want the numerator and the denominator to fall in the outer column, as we'll see here. So I'm going to start with the numerator, bringing that into the inner column. We got the number of directors desired. That's going to be 5. We want 5 directors out of the 9. That's what we're looking for, locking down in our vote 5 out of 9. Outstanding shares are going to be 250,000. So total numbers of shares outstanding, 250,000 times 5, because each of those shares gets 5 votes. That's kind of how the cumulative voting will work. That comes out to 1,250,000. Then the denominator, we're going to take the total number of directors to be elected. That's going to be 9 in this case. And we're going to take that and add 1 to it to get to 10. There's the denominator. So now we'll take the numerator divided by the denominator, which is what we typically do when they get those things down to one number. That's going to be 125,000 divided by 10. That'll give us the 125,000, 125,000, and then we're simply going to add 1 to that. That gives us 125,001. So we got 125,001. So the answer to this would basically be it. But again, we kind of want to think it through intuitively to play it out and do our basic game theory type of analysis. But for a test question, then of course the answer would be the 125,001. So we're saying with the question asking, how many shares are needed to elect 5 out of 9 directors, we would need 125,001. So then you might say, well, how does that work? So let's run down a little scenario to see if we can make sense of it. So why would that be the case? Well, if we took the outstanding shares being 125,000, we said that each share represents a vote for the number of directors that are up for vote, in this case 9. That means that doesn't mean we're going to vote for each seat, but instead we get those votes and we can apply them where we want. That's what it means to be cumulative as opposed to straight or the normal type of voting system, the standard. So if we take the 250,000 times the 9, we have total votes out there at 2,250,000. Now I'm going to compare these ours to others. So we're thinking this is us, this is everybody else. Clearly there's not just 2 sets of categories, but we want to think about what we're going to do and imagine a situation where everybody else, the worst case scenario, they know what we're going to do and they're going to try to block us. And can they do that? So we want to put our position in such a way that we can't be blocked, and then we can make scenarios from there. We could say this is our safest position. Possibly if things are structured a bit differently, maybe we can make variants and take risks, from that point. But how can we lock down assuming everybody else is going to play against us here? Well, we have our shares at the 125,001, and if we take that times the nine people that are up for election, that means we have 1,125,009 votes. So the everybody else, which we're going to assume, are going to try to stop us here, that means 250,000 shares outstanding minus our shares that we have control over, 125,001, gives us the 104,999 times 9. That means that the votes outstanding that are not ours are 1,124,991. So our strategy is to take our votes here, the 1,125,009, and allocate them over what we believe the votes that we can maximize down. And we said that was going to be, we want to lock down 5 of them. So we'll take our votes and spread them over five folks. So if we were to imagine candidates, we need someone to be locked into the 1 to 9 position. Doesn't matter where they lie in 1 to 9 position. They just need to clear the hurdle. They got to get to like the finals, right? As long as they're getting to the finals, it doesn't really matter if you were the number 1 or whatnot. That's the idea. So we're then going to say our candidates are here. We can imagine more candidates than 9. We got a bunch of candidates here that could be voted on. We need just the top votes to get the top people to fall into 1 to 9. Now, the first 5, we'll imagine these are our people, A through E. Those are the people that we elected. If we elected them, and people are, following this closely, they might be able to, of course, see some of what we are doing because we're the people that elected these folks. So they might then, determine if they don't want those folks involved, then they would know who, they'd know kind of our game plan, right? And they would possibly try to take us out. So how would they take us out then? They could try to fill in not just the next 4, because these 2 are given. Let's just check the numbers out. If we have our shares, we're going to take our total number of shares here, which was the 1,125,009 divided by 5, and that means we put that's 225,002 on each person. So that means that everybody else that they were trying to work against us, we've basically given them 6 through 9. We're not even participating there. So any vote that they can put in these slots would be fine, but we have to have 5 people that all are greater than any of our 5 in order to win. So in other words, if they put like 1, 1, 1, 1, and then they put this last one something higher than us, then of course these would be beating all the 1 items. So they got to get 5 people that have an accumulative vote count higher than ours, so they can push out at least one of our count here. So the way they might do that, they're going to say, okay, we're going to consolidate our votes. We're not going to vote for any of these candidates. The other guys aren't going to vote for any of our candidates. They're going to take then their votes, which are the 1125009, and allocate them out. So let's check this out. So they could put, notice here I put the same number like it was a tie, as if we have a tie of the 225002. They could try that, and that would be a funny outcome. That would be the way you try to maximize it, the most, because then you can try to figure out this last number to maximize it. But even then, the formula, I believe, is set up there so there's no way, even in any scenario, where this number would still be a tied or higher. So in other words, if they have this many votes and they tried to tie us with these three, minus 225002 minus the 225002 minus 225002 minus 225002, then they have at the end, let's do that again, something happened, 225002 times 4 would give us 100008, and they have their shares minus their shares of 1124994. That means they have 224,983 left. And that's not enough, obviously, to kick out one of these guys here. They need this one other person to be clearing. So even if they go to the tie scenario, I don't think it's ever going to work out based on the formula, the way the formula is set up, including the adding of this one last one, I think is accounting for that. Then they can't take us out. So if we were to add up the votes here, if we were to add them up this way, these are all the total vote count. If we were then to sort them, let's put them in this column. I'm just putting the same letters over here and sorting them from highest to lowest. So remember, of course, the top 9 are going to be the finalists, right? We got the top 9. Let's see if we can line these up. So it lines up here. We got the top 9, and let's bring this up right there so it lines up. And so that goes down to E, right? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 down to E. So this last one doesn't clear it. And they tried to tie us on this whole thing. So it would be a funny outcome because all 9 here had the exact same vote total because they tried to maximize their votes for this last one, we can imagine. If there was a situation where this one was higher than all these than the rest of them, then it would be an interesting situation because there'd be one other item you'd have to go to a tiebreaker type of thing, and that would be an interesting kind of scenario. But again, even if they went for basically the tie instead of the win on these, I don't think it's going to work out at any, you can run this a bunch of different ways, but I think the reason they added this 1 to the formula is to block out that kind of scenario that could happen, right? Where there happens to be a situation where it works out, where they try to tie everything out, and you got that one last one here. I don't think it'll still work out. So that means that even though we may not be on top in terms of the winning numbers, they could clearly vote for people that have more votes than us. The point being that as long as we get people into the clearing the bar of the top 9 that are going to be there, they're going to be on the board. If they're on the board, they're on the board. There's no points for being on the board with more votes than the other person, except for political points that you can try to make an argument for in some type of political debating type of way, possibly. So that's the idea.